let's get started. Today's lecture 5, AD 900 to AD 1230, basically the beginning of the Middle Ages. At this point we have the dawn of gunpowder. Gunpowder really came out of the tradition of Chinese alchemy. Originally, Chinese alchemists wanted to find gold or find the elixir of immortality. So experiments in alchemy in China date as far back as 100 BC, at least in terms of records. It's likely people were experimenting mixing things even before then, especially through the Chinese medical history. Alchemists tended to mix and heat materials in various combinations and try to see what comes out. As early as 142, Wei Guiyang wrote about having developed an explosive mixture, which was composed of 3 different powders. He didn't specify which specific powders they were, but the only general type of mixture that tends to fly and dance when heated would be something related to gunpowder. So it's likely that that mixture might have been some sort of prototype gunpowder, which was then very quickly forgotten. Then around 300, there was another alchemist by the name of Ge Hong, who mixed together saltpeter, charcoal, and some pine resin. And he reported that that also gave him some smoke and some fires. By AD 850, there were a number of different combinations which approached gunpowder with sulfur, charcoal, and saltpeter in combinations with other materials. And usually these were listed as warnings what not to mix for future alchemists, because the descriptions literally wrote that when people mixed this and heated it, it burned their faces, burned their entire houses down. So don't try these mixtures, they are very dangerous. Around 900 AD, some enterprising Chinese military personnel realized that these dangerous explosive mixtures might be very useful in war. The first possible usage of gunpowder in war would have been the siege of Yuzhong in AD 904. In this case, there were basically just ceramic pots filled with gunpowder set on fire and catapulted into the city. Also, it is possible that at the siege of Yuzhong we have the first use of something called the fire arrow. And the fire arrow would have been the first standardized gunpowder weapon. The very first fire arrow was essentially a regular arrow with a bag of gunpowder and a fuse at that bag that was shot from a bow to basically be used as a very, very long-range explosive grenade. It's possible, or it's very likely, that these were invented shortly prior to AD 900, because by the mid-900s there's fairly ample records of them being used by different militaries. By 969, the subversion of the fire arrow came up, which used a small gunpowder rocket fitted to the arrow itself, so as to give it more flight range. And at the top of this rocket, there would have still been the little bag of gunpowder intended to explode when it hit or when the fuse reached it. So you now have technically the first rocket-propelled weapon, but it was still fired out of a bow so that you could set the initial trajectory. And evolved variants of the fire arrow were used by various Chinese tribes, militaries, and emperors well into the 1500s. From the fire arrow, we move on to the fire lance, which can be considered as the grandfather of the gun. It's possible that this would have evolved from just a small gunpowder charge at the end of a regular spear that would have possibly been used just to shock the enemy before engaging, because if you light the fuse and the enemy is coming up and they're closing and everybody's pointing spears at each other, and then you have 1,000 gunpowder pellets blow up in the enemy face, they will probably not be very happy about it, and you can attack them much easier. Later versions of the fire lance had were made large enough to fire small pebbles or various debris, so it effectively acted like a miniature, very short-range shotgun, which could get pebbles out to maybe a distance of 10-15 meters. Still more for shock and awe rather than actually killing people, but we see the idea of using gunpowder to propel something out of a container. Early fire lances would have been made out of a very thick piece of bamboo, or bamboo reinforced with various ropes. The oldest depiction of a fire lance is believed to be dated to 950 AD. It is from a Buddhist silk banner from a place called Duhuang, and from this particular image, it's believed that this weapon held by one of the evil entities besieging Buddha is a fire lance. This barrel would have originally, like I said, initially been made from a bamboo stem, but eventually they evolved into using metal, specifically iron barrels, for their fire lances. On this image, also, what is something that is believed to be an early grenade is also shown. This would have been just another ceramic pot with gunpowder thrown at the enemy by hand instead of by catapult, as we saw from the siege a little bit earlier. Around 1040, we see the creation of a very important document that shows a lot of Chinese innovations in gunpowder, the Wujing Zhongyao. This was the first large-scale Chinese encyclopedia of war. There were a number of them written in further centuries, but this was the original one. It was compiled by a number of military scholars, including Zheng Guoliang, I'm probably completely slaughtering these names, Ding Du, and Yang Weidei for Emperor Renzong of Song, who is depicted in the image. And in the Wujing Zhongyao, they made a very exhaustive catalog of gunpowder weapons, catapults, warships, and pretty much everything else that the Chinese military was using up to that point. Regarding gunpowder, they have the Wujing Zhongyao includes the oldest complete gunpowder formulas recorded anywhere in the world. 3 different primary formulas are provided. One is for explosive bombs that would be launched by a trebuchet. Another is an explosive incendiary bomb put into a ceramic case with hooks, so you could mount it onto wooden buildings, and it would explode against the wall and set the entire wall of the building on fire. And a third type of gunpowder, which would produce poison smoke, which could be thrown at the enemy and then basically smoke out either defenders of a city or smoke away an invading army. In addition to gunpowder formulas, ceramic smoke bombs and grenades are specified. There's a fairly large variety of them, including ones with various barbs, so they could be used to latch onto buildings or other nooks and crevices. Just regular, simple ceramic bombs, grenades with ropes, and quite a few variations on the theme. Fire arrows of many different types, with different types of rockets, different sizes of rockets for different range of flight. Also fire arrow launch devices that could launch multiple fire arrows at once, including bundle baskets which would be held by a person, who presumably would light either just a single fuse for the entire basket and then let off the fire arrows one by one, or individually light the fuses on the fire arrows, but essentially you have a single device which is able to launch many of them at once, instead of having to rely on a bow and arrow to launch each one individually. Also, bundle boxes, which from their design it would appear that this box would also require just a single light to launch all of them in one go, or more likely in series. So essentially the grandfathers of modern multiple rocket launch systems, but in 1044 AD. In addition to fire arrows, there's the mention and the description of the design of the Chinese flamethrower, specifically the 2-piston bellows pump flamethrower. This would have been able to provide a stream of flaming liquid, and it was worked by a single piston pushrod, which is shown here, that would be put through this upper section and then worked against these 4 pipes, which would go into the internal hearth that held hot oil. Such a weapon was first described in battle in AD 919 at the naval battle of Lanshanjiang. In this case, the fleet of the Wuye Kingdom had a number of flamethrowers on board, and they used something which was referred to as fierce fire oil that could not be put out by water. So it's possible that this was either a acquired or a stolen derivative of Greek fire. It's known that the Byzantine Greeks had some trade connections with the Chinese Empire, which exchanged certain ideas, so the Greeks ended up getting the traction trebuchet, and it's possible that the Chinese ended up getting Greek fire either by official or unofficial means. It is also known that some of the early versions of this flamethrower used a slow-burning gunpowder mixture to light the oil as it exited the stream. So this would have actually been the first time that gunpowder was used for something military, but not to explode, but rather just to light the oil coming out of the flamethrower. In addition to these devices, they also have more conventional weapons, such as various siege engines. In this case, a number of protected carts are shown, a cart with a large number of spikes just to protect against an invading army, a simple covered cart which could be used to help soldiers get close to the walls of a city that they're besieging, a cart with a wall that could be elevated, perhaps to storm the gates and protect your soldiers before they reach the gate, and then raise it so that they could run directly into the gate. Observation carts, which could be pulled to a locale of battle, and an observer could be sitting up high so that he could report on enemy movements. or help the commanders know what's happening to the entire army that is out in the field. Various wall climbing equipment, including various hooks on fairly large, basically sticks, or hooks with ladders connected to them, or just various ladders on wheels that would be used to besiege a city and help the soldiers scale the walls. A large number of various siege crossbow designs, including double crossbow and even triple crossbow. These would have been significantly heavier than just the regular handheld crossbows, but if mounted on either a movable cart for besieging a city or mounted on just a stationary platform in order to defend a city against siege, these could provide significantly more power than just a single crossbow, because all of a sudden you have the flexion of 3 arms instead of just the flexion of 1 arm to propel your bolt. And of course traction trebuchets, going all the way from just a simple trebuchet with a conventional single rod and a bunch of ropes to something significantly more exotic, like 5 trebuchets in one platform that would all be pulled by individual teams, to traction trebuchets on wheeled platforms, and a large variety of other subtypes. In addition to weapons, the Wujing Zhongyao is the first document to mention the design of a compass. In this case, this was something called a thermoreminant compass, or the name referred to it in the Wujing Zhongyao was the south-pointing fish. A heated iron object in the shape of a fish would be suspended in water. It was magnetized by first taking the object and heating it until it began to glow red hot. And after this, you would orient the object parallel to the magnetic field, and you would rapidly quench it in water. And that process of heating and then rapidly quenching while parallel would induce a very slight magnetization in the object, and then it could be used to point in the direction of north after the cooling process is ended. It was first used at sea around 1120, and eventually evolved from something that looked like a fish that was suspended just in a complete bowl of water on a string to something that looks more like a spoon, where the bottom of the spoon would have been essentially a point contact, so it could easily rotate in whichever direction you wanted it to if it was trying to point north or south. And talking about naval developments, the Wujing Zhongyao gave the first fairly complete record of warships that the Chinese used in war up to that point. This included tower ships that occasionally would have been fitted with trebuchets on top, so effectively one of the first examples of naval artillery that is known from China. Combat junks of various shapes and sizes that would basically take the concept of the junk ship in general and then apply it either as a troop transport or as a combat platform. Covered assault ships, which were first used at the Battle of Red Cliffs. These were discovered as being covered by leather and could be used to bring troops to storm or basically assault a beach. So unlike a junk, there would have been presumably some amount of ladders or some other device to make it easier for troops to run directly off of the ship and storm a ground object. Something called flying barks, which were probably lighter ships which could move quicker and perhaps used as patrol vessels, and actual patrol boats, which were described as even lighter than that and were used for coastal duties and protecting of ports and major locations like that. And something called Seahawk ships, whose description is not particularly clear, but perhaps used as transports for troops as well. And of course, primarily a major weapon to be used against other ships, the fire ships, which came in a variety of shapes and sizes, from rafts with a large fire bundle to actual ships with a large fire bundle, whose purpose would be to basically approach an enemy fleet and set fire to the enemy fleet just by burning themselves. And on the smaller scale, the Wujing Zhongyao also documented updates in the devices provided for the infantry, including a fairly large variety of polearms. In this case, we see polearms which have axes, swords, barbs, very large spearheads, and even something like regular battle axes as heads. Also a fairly large variety of maces and flails, including flat maces, spiky maces, spiky flails, and so on and so forth. So that is the Wujing Zhongyao. It documented much of what the Chinese had available for their military at the time. A similar, or not similar, but a close geographic neighbor of China at the time, the Angkor, or the Khmer Empire in modern-day Cambodia, had taken a few of these developments that the Chinese did, and then took it a few steps further. The most impressive contribution that was not seen really anywhere else in the world was by taking war elephants and then putting artillery mounts on them. So this would have been primarily double or sometimes triple crossbows that were developed earlier by the Chinese, which were mounted on small platforms on war elephants and then used to either be fired against large armies of invaders or against cities that were currently being besieged. So this would have effectively been one of the first examples of mobile artillery out in the field, something like the Roman carro ballista that we saw in the previous lecture. From Far East Asia, if we move to Europe, we see the beginning of Northern European shipbuilding. The first ships that are described as having been built by any Northern European tribes were ships that were built by the Gallic tribe, the Veneti, who lived in modern-day Britain and France. These were first described by Julius Caesar in 56 BC, and his description identified the primary qualities of these ships as well as the reasons for those qualities, because he had to face them in battle on the sea, and it turned out that Roman galleys were actually fairly inferior in the conditions of the Northern Sea as compared to these Veneti ships. So primarily their differences were that they had a very flat bottom, because the waters in the North Sea can be very shallow, and this was different because the Greeks tended to make their ships long and narrow with a deep bottom, but these had a flat bottom, therefore they were higher up in the water. The prow and stern were built up to be fairly tall to manage the high waves of the North Sea. The structure was made out of thick oak beams, and sometimes these were reinforced by iron chains for extra strength. So compared to these ships, the Roman galleys were very easy to break because they were made out of significantly thinner planks that were not joined together quite as reliably because they were primarily intended for coastal Mediterranean work. And the sails of the Veneti were described as having been made of hide. Caesar had hypothesized that perhaps the reason hide was used was because they did not have a good textile industry, but he also mentioned that it is very possible that the real reason for hide is that simple textiles, like the sails the material used for the sails of Greek and Roman galleys, simply would not survive the high and very dangerous winds that you find in the North Sea. Moving on from the Veneti, we get to the Knightem boats, which were found in Denmark and dated to approximately 310 AD. And this is the oldest type of boat that is representative of European shipbuilding. It's the oldest known clinker boat, or clinker-built boat. A clinker-built boat has hull plank edges that overlap over each other, and they're held together by iron nails throughout the entire structure. This is different from the Mediterranean mortar and tenon, I believe, method, where individual beams would be cut so as to fit together like Lego bricks instead of overlapping. In this case, all of the beams are overlapping at least one other beam, and they're held together with significantly more strength by thick iron nails. Also, within this boat there is internal rib structure to reinforce the shell of the boat, and there's significantly more ribs than the Greeks and the Romans usually provided for, because this boat needed to be much stronger. The dimensions of this particular boat are 23 meters in length, a beam of 4 meters, a draft of 1.2, and it had approximately 14 oars per side, each of which would be manned by one oarsman. Something very similar in construction, but significantly larger and significantly later, so we're looking at a jump of around 700 years. The next oldest ships that we know of are Viking longships, such as, for example, the Skuldelov ships, which have been dated to around 1030 AD. There are some older Viking ships that have been also found, but they're generally in significantly poorer condition. So the Skuldelov ships are considered to be one of the best early Viking ships that we know of in terms of preservation. With the Skuldelov ships, there were 5 ships discovered of various sizes and basically for various purposes. In general, these were essentially the exact same design as the Knightem boats, but were built deeper, sturdier, and significantly larger. So in this particular case, you can see some of 4 of these Goldilocks ships. The very large one right here, a smaller one in the back, a medium one, and then another smaller one, and there's a person for scale in the back over here. So in this case, the ships carried a single large square sail. The Knighton boats carried no sails at all, but it's possible that it's because it was just a coastal boat that had no need for a sail. The oars, in this case, were struck through the tall sides rather than just over the top. So on the Knighton boats, the oars were just positioned over these hooks. In these Goldilocks ships, they're positioned through holes out in the side. So this is a recreation of one of the Goldilocks ships that is seaworthy and being used for essentially experimental archaeology and seafaring today. So you see that the oar ports are stuck out the sides and they're covered in leather so that when you stick the oar out, it makes a completely watertight exit. And also, in addition to the slight construction differences, these Goldilocks ships were given a single wooden plank deck. There's no evidence for having like a specific deck on the Knighton boats because they were so small, but with these ones with their significantly larger girth, they had a single deck on which the Vikings would sit, and presumably they might have, while rowing, they might have sat on something like sea chests or just regular, some sort of stool-like construction. But there were no stools that were actually built in for permanent row positions on these ships. Similar ships were used for a fairly long while and by a large variety of Northern Europeans. One of the most impressive fleets assembled of Viking longships were used for William the Conqueror's invasion of Britain. William the Conqueror was a prince from, or essentially a king from Normandy, who decided to invade Britain in 1065. His fleet was reported to have used 726 ships. This was comparable with the largest fleets of conventional Vikings up from the more northern areas. Some of the fleets that attacked Paris were reported to be as much as 700 ships, so of a similar number as this one. And what we see is the ships that would have been used by William the Conqueror essentially have the exact same type of construction as Viking longships had perhaps for 1 or 2 centuries up to that point. And there was a fairly extensive representation of these ships on the Bayeux Tapestry. Some of the ships are seen here, but on the Bayeux Tapestry it records how the ships were built, how they were operated, how they were used to transport the army to Britain, and eventually how they were dragged ashore and essentially just left on shore because the army had no intention of returning to Normandy at any point in the near future. One of the derivatives of the Viking longship was the Russian war ladya. This would have been primarily for river or coastal operations, and a couple of primary structural differences from the longships is that it would have been smaller and lighter than the very large oceanic longships, and the sides were raised with additional boardwork. This would have provided additional protection for the rowers and the crew from any people attempting to attack with arrows or javelins or various other thrown devices. Also, just like the Vikings, it would be common to see the ladya covered with shields of the rowers along the sides. That way the shields provide additional protection for the rower while they're rowing, and then when the entire ship is ready to beach and attack some land target, then the ships are simply picked up and used in battle as regular shields. One of the major uses of the ladya was essentially raids, because just the early Slavs had quite a bit of interaction with the Vikings, and one of the most impressive feats of essentially Russian raiding was Oleg of Novgorod's campaign against Byzantium. This was recorded in Russian annals to have happened in AD 907. This particular raid is not recorded in Byzantine annals. They do record one that happened 4 years later, but it is possible that simply the record of that particular raid from the Byzantine side might not have survived to this day, or it might have simply not been yet discovered. For this raid, Oleg reportedly used a fleet of 200 ships with around 40 warriors each. The Byzantines raised the harbor chain, as they usually did, to prevent him coming to the weaker protected port of Byzantium. So what he did was he took his ladya and basically put them on giant carts with wheels, and then reportedly sailed them right across the opposite shore and right into the Golden Horn. And when the Byzantines saw that the entire fleet was essentially right up against the weakest wall of Byzantium, they decided to sue for peace and gave him tribute, rather than having him take the city and start burning and pillaging as he was threatening to do. And the ships on wheels are represented in this ancient Russian painting from the Russian annals. And this is essentially the Emperor of Byzantium with his crown, trying to offer tribute to Oleg of Novgorod. And the same thing is drawn in a slightly more realistic fashion down below. In the following centuries, the Northern Europeans began to add forecastles and stern castles to their longships. Especially this was first done by the Vikings. Similar forecastles were seen on Roman war galleys when they took the Greek trireme and bireme and added forecastles to them. And the reason for adding these forecastles was exactly the same as the reason that motivated the Romans, is that you wanted to provide an elevated platform for archers to be able to shoot down at the enemy in boats who did not have these forecastles. And on the earliest Viking warships that had these forecastles appeared around 1000 AD, and they proliferated as time continued. Around the 1100s, when you get to the period of the Crusades, we see larger, heavier trading ships being adapted to use as warships. Initially, these would have essentially been just basic trading ships used by traders from Northern Europe to go as far as the Mediterranean and trade their goods, like silk, spices, foods, salt, and so on and so forth. As these ships were begun to be used for war, initially the exact same type of ship would have been used as a transport for a fairly large number of soldiers instead of cargo. And as soldiers began using these ships more and more, they installed forecastles and aftercastles into these ships as well. But unlike installing just a simple castle that sticks out of the framework like a sore thumb, these castles were more integrated into the structure because these ships were larger and could take on basically more woodwork that required the addition of more essentially flush forecastles and aftcastles. We also see the use of lateen sails, which were borrowed from the Mediterranean cultures, such as the Byzantines. And we see that on these ships, side rudders are still used for controlling the direction of the ship. The stern rudder has not been yet invented, and we will get to that actually in the next lecture. At the same time, we have early Japanese warships. There's fairly little record about naval warfare in Japan in terms of the types of ships that they used, with the exception of the fact that they were mostly fairly light and essentially basically derived from trading ships. These would have primarily been used as transports because most of the warfare done in ancient Japan was on land, so primarily naval warfare would have been to just either send a group of transports to invade another island, or to try to meet that group of transports and prevent it from invading the island that they were trying to invade. The designs of these ships would have been fairly similar to the Chinese junks because there was a bit of interaction between the Chinese and the Japanese in terms of their shipbuilding and their culture and so on and so forth. A good example of early Japanese naval warfare was the Battle of Mizushima in 1183. In this case, one of the navies took most of their ships and actually joined them all together using planks, and that essentially made their entire fleet just a single dry land battlefield out in the middle of the ocean, basically an island of ships. And when they began the battle, they began it with a long-range artillery attack, but it essentially came down to winning a gigantic land battle at sea on a artificial wooden island. And the side who was able to join their ships and get all of their warriors to bear in any point of the battle, they won fairly easily. Another major example of, or another major case of ancient Japanese naval warfare was the Battle of Danawura in 1185. In this case, once again, most of the fighting was done by boarding operations, and the side that won by boarding the ship with the emperor of the Taira clan and assassinating the emperor and the entire royal family and that particular clan's leadership. So this led to Japan being dominated in the following decades by the Minamoto clan. And a painting of the Battle of Danawura is presented here. An interesting consequence of the Battle of Danawura was the development of this curious little thing called the Heike crab. The Heike crab is a type of crab which has a carapace which is deformed in such a way as to somewhat resemble a human face. And it is believed that these crabs would have appeared because in the aftermath of the battle, some of the Taira clan survived, but they were demoted essentially to the status of peasants in Japan. And it is possible that when they were fishing for crabs to basically feed their families or to sell in the markets, they would have noticed that some crabs had a face that looked vaguely human, and they might have believed that it was actually the spirits of their own soldiers who sank in the Battle of Danawura, and then thrown those crabs back into the sea. And over the course of several centuries, this sort of non-intentional artificial selection would have preferentially developed crabs with carapaces which look more and more human. So nowadays we have very human-looking crabs that were essentially thrown back into the sea for generations and generations out of respect to the deceased Taira soldiers at the Battle of Danawura. A little note on castles. So you can't really talk about anything in the Middle Ages if you don't talk about castles. But castles themselves as a thing are new. Fortifications, however, are not. Fortifications are really as old, or in fact older than language itself. This is an example of the Ness of Hrodgaur in Scotland. This was a fortification built around 3200 BC with stone walls as thick as 6 meters. This would have been some fortification used by local tribesmen to protect their territory against enemies. And similar fortifications were found even earlier on throughout much of Europe, in going back as far back as 4000 and 5000 BC. As cities grew, cities were given very large walls to protect the entire city. A famous example of large walls in ancient cities were the walls of Babylon. These were described as over 12 meters tall and wide enough to raise 2 chariots along the top, so presumably on the order of 10 meters or perhaps more than 10 meters in thickness, and also built up of stone. In this particular case, what you see is the main entrance to Babylon through the gates of Ishtar, which were described as having been decorated with bright blue paint and golden carvings of various Babylonian deities. Smaller walls were used for millennia to defend forts, or specifically military installations, either at the borders of a country or inside enemy territory as a nation was trying to invade another nation. This is an example of the Roman Rochester fort in Britain from AD 200. Clearly this is much smaller than a city. It's just essentially a barracks and living area for the soldiers as they are out in the provinces, so that they do not have to sleep out in the open. This was actually one of the forts that was built along Hadrian's Wall. The wall itself can be seen intersecting the fort, and that was a wall that was built by Emperor Hadrian near the border of Scotland to protect the northern territory, or the southern territory of Britain that was controlled by Rome, against the barbarians that lived up in Scotland, who occasionally pestered the Romans with their attacks. We get to castles as the Roman Empire falls. The Carolingian Empire briefly rises up and then falls as well. So Charlemagne, king of the Franks, founded the Carolingian Empire in 8800. He was crowned emperor by the Pope of Rome in an attempt to try to revive the Western Roman Empire, as the Eastern Roman Empire was the only Roman Empire that was functional at the time. And he essentially founded a fairly large empire, so everything that's gray here was the Carolingian Empire. But as his descendants continued to basically bicker and fight amongst each other, the empire finally split up in AD 888, and it split into more than 10 individual kingdoms, and the kingdoms were further fragmented into individual dukedoms and countdoms and so on and so forth under the feudal system. So because of the feudal system, we get to castles. A castle is essentially a reinforced manor of some local lord, perhaps a count or a duke, with additional protection for any peasants who might be living underneath them, but it's primarily a reinforced mansion. The first castles that we get appear around AD 900. This is an example called Donjon du Falcon Noir, or the Dungeon of the Black Falcon. This was built in 995 in France, and the castle is, in this case, just a very, very simple construction, a square or a rectangular stone building with a small tower for decoration, and then the remains of an outer wall which protected a courtyard. The castles were built by these lords to essentially protect their own holdings. This was to protect their holdings from each other, so from other counts and dukes, to protect their holdings from the king in case the king wanted to come in and take something, and to protect it from invaders such as Vikings or the Mamluks and so on and so forth. It is believed that the invasions of the Vikings and the invasions of the Muslims into Europe might have been some of the major motivators to develop more and more castles through the early Middle Ages. There is a very rapid proliferation of the construction of castles around 1000. Obviously, initially in France, where castles were first born. Spain started having proliferation of castles around 950, as well as Italy. England began constructing castles in 1066. These were introduced to England by William the Conqueror, who came essentially incidentally from France. And the rest of Europe sees most of the rest of European nations see the beginning of at least some amount of castle construction by around 1100. The major, I guess, event that precipitated the construction of castles in any one particular nation would probably be in England. These were first built by William the Conqueror himself, and they were the main means by which he established control over the island eventually, because even after he beat King Harold at the Battle of Hastings in 1066, he still had a full island of Angles or Anglo-Saxons who did not particularly want to be ruled by the Normans. So what he did was he built a large number of fortresses where the Normans lived and were protected, and in case the Anglo-Saxons wanted to attack, they could just retreat into the castle and then either wait the siege out or call for help from other castles and then attack the besiegers at some particular location. So in that effect, castles were sort of the main chess pieces through which William the Conqueror and the Normans in general solidified their control over the island of England. A famous example of one of William the Conqueror's castles is the White Tower. This is the main keep of the Tower of London. It was built in 1078, and it was built over the site of an earlier castle that was built by William immediately after his invasion. So once he had England mostly underneath his control, he solidified and rebuilt a lot of his early fortifications, which had been made out of mud, into significantly sturdier fortifications built out of stone and heavy masonry work. It's difficult to give a single, basically, blueprint of a castle, because castles were built by pretty much every single lord to his own liking. But it is possible to identify the anatomy of a generic castle by the common features that pretty much all castles shared. The most important part of a castle would be the keep. This was essentially the lord's manor, which was the most reinforced and usually the tallest part of the castle, where the lord and the remainder of the castle defenders would retreat to make a last stand in case the rest of the castle was breached and invaded. Usually, in addition to the keep, there would be a fairly large outer wall, which was called a curtain wall, and in between sections of this wall, you would have towers. So you'd have sometimes square towers, sometimes round towers, sometimes towers of various other shapes. But essentially, these towers would be serving as protective devices, where on the top you could have defenders with bows and arrows, defenders with various anti-siege weapons, defenders with perhaps long-range crossbows or weapons similar to those that the besiegers might use, perhaps their own catapults. And in essence, the towers had to be spaced closely together as to cover each other's lines of fire, but also far enough apart that you don't have your entire castle just be consisting of towers alone, because that would significantly complicate and lengthen the construction time. In addition to towers and walls, the internal structure of the castle would have been divided into these things called baileys. These are essentially open courtyards where either the commoners who lived under the lord would live, or the soldiers who lived and served the lord of the castle would be stationed and kept. That way they didn't have to retreat into the castle in case of an attack. They were already in the castle, so they were always prepared to defend basically at a moment's notice. Occasionally, for larger castles, there would be an arsenal tower where the majority of the weapons would be held. So these would include the weapons for the soldiers, as well as counter siege weapons to protect the castle against heavy invading siegers. And of course, very often the castle would be surrounded by a moat, essentially a hole filled with water, so that invaders could not simply walk up to the walls of the castle, but had to cross some sort of water-based barrier. And in order to make sure that the lord and the castle's own occupants could easily cross that, there would be a drawbridge that could be drawn back up into the castle for protection against invaders, but in times of peace would be lowered and act as a bridge across the moat for anybody who wanted to leave or enter the castle through permitted and legal means. And we can, while it is not really feasible to characterize castles by their overall shape because there's much too much variety, we can characterize them by their overall organization. The earliest types of castle were called motte and bailey castles. These would usually consist of a motte, which is essentially a man-made hill, on the top of which would be a keep, typically made out of wood, and protected by a wooden fence. And next to the keep that would be sitting on the motte, there would be the bailey, so as I mentioned, the open courtyard, where the commoners who lived under the lord would be situated. So in case of an attack, the bailey itself would still be protected by the moat and the wooden fence, but if the bailey was taken, it was still significantly more difficult for invaders to take the keep because it was significantly taller and could be better protected and would have all of the primary defensive weapons of the entire construction. As we look at castles that begin to use stone rather than just wood, one of the simpler ones would be called a tower castle, which is essentially just the keep alone, surrounded by a wall and perhaps with a small courtyard, but without quite the extensive internal structure that you would see with later castles. We get to the most recognizable type of castle, or the rectangular keep castle. These would usually consist of a single major keep in the center of the entire construction, and that would be surrounded by a wall on all sides, but not necessarily intersecting that wall at any point. And in this case, the keep was literally the beacon of the castle, so this is where everybody would rally for the defense. And on the inside of the rest of this, you could have houses for the commoners, shops, markets, and so on and so forth. This is an example of the Dover Castle in Britain that is a very, very good example. So most of the time when people think of castles in movies or TV shows, they usually think of the rectangular keep type castles. In addition to the rectangular keep, there's the type called the shell keep castle. This is an example called the Restorma Castle, I believe also from Britain. You can see the remains of the moat around the castle. This would have originally been filled with water, but over the course of a few hundred years, the water had completely dried out, and we just have a dugout moat. In this case, there is no keep to specify within the construction. It's just that the entire wall is specially reinforced and acting as the entirety of the keep. So whatever courtyard you would have been just the central courtyard in the entire construction. These might have been somewhat cheaper to produce if you just wanted to have a small castle, because then you didn't have to waste the additional resources to build an extra wall and an extra building inside of that wall for protection. You also, as warfare in the Middle Ages progressed, you began to find yourself needing to have more and more and more protection. So people ultimately began to build something called concentric castles. This is an excellent example called Crac de Chevalier. It was a castle built by the Crusaders in modern-day Syria. The ruins are actually still present and I believe can be visited. So in this case, we see there is an outer wall that is essentially built as a cliff to be almost a natural barrier for any invaders. And this wall is protecting an inner courtyard, which is then separated into subsections by further walls. And then inside this courtyard, there is another wall which protects another inner courtyard, and so on and so forth onto several layers. So in order to take a castle like this, the enemy would have to expend significantly larger amount of resources as opposed to one where it's protected by just a single wall and has a single keep somewhere in the center, or is just a shell keep. So as the Middle Ages progressed, the wealthier barons and dukes and duchesses would eventually choose more and more and more concentric castle structure, but perhaps with outer walls being much less impressive than what you see with the Crac de Chevalier. There were a large number of similar constructions in the non-European world that would technically be classified as castles as well. The Muslim world built a large number of structures that were similar. This is for example, Saladin's Citadel of Cairo. We see that the architecture is somewhat different because they have, like, for instance, a mosque as part of the structure, but the overall idea of having a protected small locale where you could rally all of your troops and defend them or improve their defensibility is seen here. Japan, when it went through its feudal phase right around the same time that Europe went through its major feudal phase, also had a number of castles. This is Himeji Castle, one of the more famous ones in Japan. You can see that most of the construction is built on top of a very, very steep stone structure. So instead of acting as necessarily a wall, it just raised the castle above the ground, making it more difficult for invaders to try to breach the defenses of this of the keep. In China, or specifically in Tibet, we see a number of zongs built. These were specific mountain-based castles, so they were already built in the mountains, which are difficult to get to. So when you add the very, very difficult rough terrain of Tibetan mountains with thick defensive stone walls, you have something that is very, very difficult to punch through and invade indeed. And you also have construction of similar forts or similar castles in India. This is an example of Miranga Fort. In India, these were mostly built towards the later era as gunpowder weapons proliferated. So on average, the walls of these late Indian forts would have been much thicker than the walls of earlier European castles, because they were actually intended to take the brunt of very large cannons being fired against the fort and hopefully keep the occupants and treasures and whatever else safe within. In response to castles, we have the development of a new weapon, the counterweight trebuchet. The first trebuchet that used a counterweight rather than a series of men pulling down, that would be called the traction trebuchet, was probably developed around 1100. The earliest record that might indicate the use of a traction trebuchet was the siege of Zevmignon in 1165. There is a possibility that something like a counterweight trebuchet could have been used even earlier, around 1109, because there was a description of using a catapult that was a trebuchet but with a winch, and it doesn't really make sense to have a winch used together with just a traction trebuchet. But because that is the only description available, it's uncertain what specific type of trebuchet was used there. So we have to rely on more record from Zevmignon in 1165. And the first clear description of a counterweight trebuchet's construction and design is from 1187. This was from a military manual written by Mardi ibn Ali Tarsusi. That was written specifically for Saladin, as Saladin was expanding his authority over the Middle East. He wanted to learn about more types of weapons and have that information be available for his army, so Mardi basically wrote a manual that was then proliferated throughout Saladin's army. The counterweight trebuchet is more effective than pretty much all earlier types of artillery, because while earlier types of artillery either relied on the flexion of wood or the torsion of large sinew springs, the counterweight trebuchet only requires the potential energy of a large weight being raised to some height and then allowed to drop. So ammunition fired by historical counterweight trebuchets was recorded up to 800 kilograms. You couldn't really get an 800 kilogram ball to go much of anywhere with a ballista or with a traction trebuchet, but with a counterweight trebuchet of sufficiently large size and sufficiently sturdy construction, would be able to throw an 800 kilogram boulder against the walls of some city or some castle with fairly good reliability. Typical ammunition, around 100 kilograms, would be thrown to a distance of 300 meters. This is much better than the distance you would get on most earlier types of artillery as well. So if the defenders had other types of catapults, the trebuchet could basically be put out of the range of the defenders' catapults and repeatedly batter the walls and the city over and over and over again, with the city being completely powerless to stop it unless they essentially mount an attack to go out and attack it with their own soldiers. And well-trained crews could essentially launch up to 2 rounds per minute with a good trebuchet. And from the design of the trebuchet, there are a few primary components. You see the counterweight, which would usually be a wooden box that will be filled with stones to achieve the desired weight. There is the arm of the trebuchet, with the longer arm being provided at the top and the counterweight being given the shorter end of the arm. The sling, which would hold the boulder to be slung, is connected through a rope and to a hook at the top. The angle of the hook could be set to make sure that the sling is released at the proper angle of exit. So if you wanted to have a more direct fire, you could set the angle to be lower, or if you wanted to have more ballistic fire, you could set the angle to be higher. There's a story from the Middle Ages where one trebuchet crew did not set their angle properly, and they sent the stone directly vertically upwards and landed on the trebuchet and completely crushed it. So that was possible as well. The way that the trebuchet was loaded was the sling itself had another rope that was connected to a winch, so winding this winch would lower the arm. You'd be able to load in your boulder into the sling, and then release this winch, which would then have the entire weight of the entire counterweight descend down and launch the projectile. A slightly more fanciful loading of the trebuchet is provided in this trebuchet at Warwick Castle. It's a modern reproduction, and in this case, the way that they organized the winch in the back is that instead of being operated by men with very strong arms, they have the winch connected to essentially a hamster wheel, where people walk inside of this wheel, and by walking inside of the wheel, they pull the winch, which then draws the arm back and allows the mock soldiers to load new rounds into the trebuchet. This is essentially, or in principle, this is the largest trebuchet that was built in the modern world, but it's possible that earlier, during the High Middle Ages, somewhat larger trebuchets than even this could have been constructed, especially the ones that were described as launching 800-kilogram boulders. The trebuchet continued to be essentially the dominant type of artillery in Europe until the introduction of gunpowder, because of how effective it was in comparison to other types of artillery, and these were last used in battle around 1480. And incidentally, what eventually took over the trebuchet as the primary weapon of siege was the cannon. It's likely that the cannon would have evolved from a metal variation of the fire lance, where initially the fire lance, as we saw earlier, had a bamboo barrel. This was later replaced by small iron barrels, but still the amount of gunpowder that they could carry was very small. The earliest cannons would have not been significantly larger than what you would have seen on a fire lance, and would have been primarily carried in hand. The oldest, what is believed to be the oldest representation of a hand cannon, can be found in the rock carvings in Dazu caves, and has been dated to 1128 AD based on circumstantial evidence. In this case, we see a man holding a very bulbous object, and this is very common for early cannons to have a bulbous section in the back where you could load in your gunpowder and your projectile, and have a narrow neck to release all of that. We see that this bulbous body is emitting a blast of fire, and it would have also been represented initially emitting a ball. The ball itself has been lost, unfortunately, but the impression from the stone ball of the carving still remains, so very likely this is the earliest representation of something like a hand cannon that we have available. As metallurgy experience grew, especially in China, where the first gunpowder weapons were developed, cannons also began to grow larger, because now you could make larger castings, larger shapes out of metal, and that would be the metal itself would be stronger. The oldest discovered cannon, and incidentally the largest cannon from the 1200s that was discovered in China, is the Wu Wei bronze cannon. It has been dated also circumstantially to approximately 1220. It is possible that it could be a later design, but based on evidence, this is the most likely date. This cannon is fairly large for the 1200s, at 1 meter in length, a mass of 108 kilograms, and then a muzzle caliber of 120 millimeters at the exit. It was discovered with an iron ball inside of it that was measured at 90 millimeters in width, but it was heavily corroded, so it's believed that it could have actually been originally matching the muzzle. It just eroded to that smaller size over the past 800 years that has been rusting around in the dirt. And right as the Chinese were developing their first cannons, the Europeans were developing their castles and were developing their various new trebuchets. We have the Mongol Empire being founded by Genghis Khan, whose actual name was Temujin. Genghis Khan was his honorific after he became Khan. Genghis Khan founded the Mongol Empire and eventually made it the largest contiguous land empire in terms of contiguous land area. The only empire that had more land area was the British Empire, but their area was split over pretty much every continent on planet Earth. Genghis Khan began his empire building when he consolidated all of Mongolia into a single state in 1206. Then his first foreign campaign was against the Western Shah, which he took by 1210. By 1215, he took another Chinese kingdom, the Jin, and another Chinese kingdom was the Western Liao by 1218. You can see the Jin right here, and various other kingdoms like the Shah over towards the north of China. Then in 1221, in order to avenge a murder of his caravan in Khwarezmia, he took and essentially burned Khwarezmia to the ground, and had various other further conquests both to the west, where he went as far as almost Hungary, and then came back and launched another campaign against China, and campaigned essentially until he died in 1227. The Mongol army was predominantly consisted of highly maneuverable cavalry units. 60% approximately would have been light archers, and 40% would be armored lancers. Everybody carried a sword for close combat, and they made very extensive use of specialists from lands that they carried. So they would use gunpowder specialists from China to make bombs and fire lances for them, and rockets. They would use siege engines that were developed by engineers from China and Persia. And in fact, initially they attempted to simply take over the technology and then kill the specialists, but after a very large number of Mongol soldiers died because they essentially blew up an entire gunpowder lab, the Mongol High Command decided to just use the foreign specialists directly because they already had the knowledge, and then the Mongol soldiers would not need to worry about having to learn all of these skills themselves. Also, in a rather inhumane move, they used very extensively prisoners of war as human shields. So in case of invading an enemy city, they would drive forward in front of them many ranks of earlier prisoners captured earlier, so that they would take the brunt of the arrow and catapult fire, and the Mongol soldiers themselves would be protected behind that particular wall. The cavalry was primarily protected by lamellar armor. These essentially consisted of plates laced together in organized rows, so there was no overlap between them. And this allowed the rider to have more freedom of movement than overlapping scale armor. Mongolian horses gave them a very, very good advantage in terms of combat abilities. They were shorter than European horses, but they're much sturdier and much better adapted to extreme climates. So these horses were able to take the brunt of the Russian winter on many, many occasions, whereas European horses would fare very badly in that kind of weather. The Mongolian horse is a very good self-sufficient forager, so as the Mongolians drove, they essentially just needed to make sure that the horses had enough pasture, and they didn't really need to worry about bringing tons and tons of fodder as food for the entire cavalry. And compared to other horses, the Mongolian horse has very, very good stamina. This meant that the Mongol army could essentially ride all day without tiring out their horses, and especially considering that usually every rider had a primary horse and a backup horse, and then he would essentially switch in between them as the horse he was riding on would get tired. This meant that the Mongol army could make a journey in just a few days that a different army would expect to take several weeks. So if reports came in of Mongols invading one side of your territory, you would be expecting them to arrive perhaps in a month, and they already arrived there just a week later, while you were still busy trying to prepare all of your defenses. And this very, very excellent mobility basically gave them a lot of shock and awe advantage against pretty much every other army that met them in battle. The Mongols, the primary weapon in combat was the Mongol bow. This was a recurve composite bow that was small but very, very powerful. You could have a good aim shot out to 150 meters and ballistic fire out to 400 meters. Mongol riders were trained to fire the bow during the moment in gallop when all four legs of the horse were off the ground. That way the horse was not at the same time hitting against the ground and disturbing the game. Therefore you could shoot very carefully, and there were stories that very good Mongol archers could hit a bird on the wing at a distance of 50 meters while at full gallop. They had quivers for 60 arrows each, and a large number of backup arrows carried with supply trains. Their arrowheads were hardened in brine. This made them generally better for penetrating armor than other non-hardened arrows. In addition to their arrows, they also had a primary close sidearm. There's a curved sword. This would have been similar to a scimitar or saber. Primarily, this would have been used for slashing an enemy from horseback, but it could also be used as a thrusting sword as well. Usually, the blade of these was around 75 centimeters long, and overall length would go up to 1 meter, but sometimes a little bit longer for two-handed versions that would have been used for combat when you get off of your horse and go into combat as an infantry. And that concludes today.